Welcome, sleepy friend, to another quiet journey with infinity beyond. Whether you're here to learn, to unwind, or simply to drift into a peaceful doze, you're in just the right place. Tonight, we'll follow a gentle trail of moonlight across the sea, exploring how the moon, that glowing pebble in the sky, quietly tugs at the oceans below. It's a slow, steady pull, not unlike the way your eyelids might start to feel just about now. Before we set sail on this lunar voyage, consider giving this video a like. It helps Infinity Beyond, this cozy corner of the cosmos, reach more curious minds like yours. Let's begin, shall we? Picture yourself on a quiet beach at night. The sky stretches endlessly above, scattered with stars. The waves roll in and out in a calm rhythm. That gentle push and pull you hear? It's not just wind or weather, it's the moon, quietly performing its ancient dance with the Earth's oceans. Tides, those regular risings and fallings of the sea, are caused primarily by the gravitational interaction between the Earth and the moon. The moon's gravity pulls on the Earth, and that includes its water. But it's not quite as simple as a single pull. There are layers to this cosmic choreography. As the moon orbits our planet, its gravitational pull creates a bulge in the Earth's oceans, what we call a tidal bulge. But there's another bulge on the opposite side of the Earth too. Why? Because as the moon pulls the Earth slightly toward it, the oceans on the far side are left behind in a way, creating another bulge. So there are actually two high tides every day in most places, one on the side facing the moon and one on the opposite side. The Earth rotates underneath these bulges, causing the water level to rise and fall throughout the day. Now take a breath and imagine how enormous this force must be. The moon is nearly 400,000 kilometers away, and yet it moves oceans. But the moon isn't alone in this. The sun also plays a part, though it's farther away. During new and full moons, when the sun, Earth, and moon are in a line, the gravitational forces of the sun and the moon combine. These moments create especially high and low tides called spring tides. And when the moon and sun are at right angles, during quarter moons, their forces partly cancel out, leading to gentler neap tides. Let's take a pause and reflect on this. The moon, so small in our sky, silent and still, has been shaping our world for billions of years. The very rhythms of life along coastlines depend on it. Crabs scuttling along the sand, coral spawning in sync with the tides, even the migrations of fish, all subtly timed to the moon's silent beat. And then there's us. Humans have watched the tides for millennia. Ancient seafarers relied on tidal patterns. Farmers in coastal areas timed planting and harvesting to tidal cycles. And in the modern world, cities rise near coastlines, ports rely on tides, and engineers calculate tidal energy for clean power. Isn't it fascinating that something so gentle, so seemingly passive, wields such power? As we drift further into this topic, think about the beauty of this natural rhythm. The moon isn't just a rock, it's a timekeeper, a sculptor, a guide. And while this episode flows gently like the tides, we'll soon dive deeper into the mysteries of tidal locking, orbital resonances, and how the Earth and Moon influence each other far more than you might expect. But for now, let's just float. Float with this thought. Every night you've ever stared at the moon, it's been silently stirring the waters of our planet. Quietly, consistently, patiently. Let the waves carry that idea through your mind. And as always, if you're enjoying this voyage, don't forget to subscribe to Infinity Beyond. We explore the universe together, one quiet question at a time. The moon has done more than just pull our oceans. It has shaped our history, biology, and even our sense of time. From the first fish wriggling into a tide pool to the ancient sailors who followed the tides, the moon has been there, guiding, influencing, whispering. Without the moon, our planet would be drastically different. It's not just a nightlight in the sky, it's a stabilizer, a guardian, a cosmic companion. Without it, Earth's tilt would wobble far more severely. That tilt, currently about 23.5 degrees, is what gives us our seasons. But without the moon's steadying gravitational influence, Earth might tilt as much as 85 degrees over time. Imagine Arctic winters at the equator. Imagine tropical jungles frozen over. The moon keeps our axis stable. And by doing that, it keeps our climate stable. At least, stable enough for life to evolve, adapt, and thrive. At Infinity Beyond, we're always fascinated by how something so distant can have such intimate effects. The moon's influence even helped slow Earth's rotation. Billions of years ago, a day on Earth lasted only 6 to 8 hours. But the moon's gravitational pull has acted like a brake over time, stretching our days out to the 24-hour cycle we know today. So every time you complain there aren't enough hours in a day, thank the moon. It's given us time, literally, but the connection runs deeper. In ancient cultures, the moon was more than a scientific body. It was sacred. The Mayans, Egyptians, Chinese, and countless others followed lunar calendars. Festivals, harvests, spiritual rituals, these rhythms of life were all tuned to the moon's phases. And today, in the background of our modern world, that ancient influence lingers. The tides come and go. The full moon still lights up our skies once a month. And whether or not you believe in lunar effects on behavior or mood, it's undeniable that the moon's presence continues to shape our experience on this planet. Now let's gently drift into a more poetic space. Imagine standing on a beach, full moon overhead. The waves reach toward your feet, pulled by a force you can't see. That invisible hand? It's lunar gravity, stretching oceans toward it. But it's not just the water that feels that pull. The Earth itself bulges ever so slightly. It's a constant reminder that we're not isolated. We are in relationship with the cosmos. That's one of the big ideas we explore here at Infinity Beyond, this interconnectedness. Every star, every planet, every moon is part of a grand system of motion and balance. And our moon, humble as it may seem, plays a role far greater than its size. It affects wildlife too. Coral reefs time their mass spawning events to the full moon. Sea turtles emerge from the sand when the moonlight shines just right. Even some trees adjust their growth patterns based on lunar cycles. Our ancestors didn't need telescopes to understand the moon's importance. They saw it in the rising tides, in the migration of animals, in the shape of the coastline. And today, we confirm with science what they sensed with intuition, that the moon is vital. And yet, it's easy to take it for granted. When we look at it now, we see a familiar face in the sky, cratered, gray, silent. But it's more than that. It's history. It's memory. It's the echo of a time when the Earth was young, and a massive collision gave birth to the moon from our planet's own crust. That origin story is one of the most dramatic in the solar system. A Mars-sized body, often called Theia, slammed into the early Earth. The debris from that impact coalesced into the moon. And since then, it's orbited us, slowed us down, calmed our seasons, lifted our ocean, not just a companion, a co-creator. So tonight or tomorrow, when you glance up at the sky, try seeing the moon not just as a shape, but as a force. One that has held our planet steady, shaped our climate, and carved coastlines over eons. At Infinity Beyond, we believe there's great comfort in understanding the world around us. The more we learn, the more we belong. The more we see, the less alone we feel. And now, as the waves of this story begin to retreat, let them take with them any tension you might be holding. Breathe out, let go, because just as the tides return, we too will return, with more stories, more mysteries, and more gentle wonders from our universe. If this journey helped you sleep, helped you think, or helped you feel a little more connected to the sky, consider joining Infinity Beyond. Subscribe, share the wonder, and be part of our growing constellation of curious minds. The moon may be the main sculptor of tides, but it's not working alone. Another massive player joins the ballet of gravitational forces, the sun. Though the sun is over 93 million miles away, its gravitational influence on Earth's oceans is still strong, about half the strength of the moon's. When the sun, moon, and Earth align during full moons and new moons, their combined gravitational pull amplifies tidal effects. These are known as spring tides. Interestingly, they have nothing to do with the season of spring. The term spring comes from the idea of the water springing forth, reaching farther up the shore during high tide and retreating more dramatically at low tide. It's the universe stretching Earth's oceans just a little bit farther, twice every lunar cycle. Now imagine the opposite, when the sun and moon are at right angles to each other, as seen during the first and third quarters of the moon. Their gravitational forces pull the oceans in different directions. The result? We get neap tides, gentler, more moderate tidal changes. Spring tides and neap tides offer a kind of cosmic rhythm, a pulse of high energy and low energy, happening over a 2-week cycle. It's like the Earth's oceans are breathing, responding to the push and pull of celestial bodies. At Infinity Beyond, we marvel at these simple, elegant relationships. These aren't violent forces. They're subtle, predictable, measured. And yet, over time, they shape coastlines, influence marine life, and even impact human infrastructure along shores. Tide charts around the world are carefully calculated using both lunar and solar alignments. Fishermen, port authorities, surfers, and sailors depend on these rhythms. Timing is everything when it comes to the sea, and the moon and sun keep the clock ticking. Let's drift a bit deeper. What's especially fascinating is how different places on Earth experience tides differently. Some areas see 2 high and 2 low tides each day, a semi-diurnal pattern. Others experience just 1 high and 1 low tide, called diurnal. And then there are places where the pattern shifts daily, mixed tides. The reason for this diversity lies in local geography. The shape of coastlines, ocean floor contours, and nearby land masses all affect how tidal waves propagate. Even underwater ridges and continental shelves can bend and shape the flow. In other words, while the forces are universal, the outcomes are unique. That's a beautiful metaphor, isn't it? The same cosmic push acts on every coastline, but each responds in its own way, just like people do. Take the Bay of Fundy, for instance. Located between Canada's Nova Scotia and New Brunswick provinces, it boasts the highest tidal range in the world, over 50 feet in some places. Twice a day, billions of tons of water flow in and out of the bay. The unique funnel shape of the bay amplifies the tidal energy, making it a natural wonder and a potential source of clean power. Tidal energy, in fact, is one of the quiet revolutions of renewable science. Unlike solar or wind, tides are completely predictable. Scientists and engineers are developing underwater turbines that capture the kinetic energy of these moving waters and convert it to electricity. It's a poetic idea, isn't it? Using the same gentle forces that have shaped Earth for eons to light our homes and charge our futures. Back to the sky for a moment. We often think of celestial mechanics as abstract, distant, something for physicists and astronomers. But tides are a tangible way in which cosmic forces touch our daily lives. They remind us that we live not just on a planet, but in a system governed by gravity, balance, motion, and time. At Infinity Beyond, we believe that the more we understand these forces, the more we can appreciate our place in the cosmos, not as spectators, but as participants. So tonight, as you lay back and listen to this quiet narrative, Imagine yourself floating not just on a sea of water, but on a sea of gravity. Pulled gently by the moon, nudged softly by the sun, in rhythm with everything. And maybe, next time you walk along the shore and see the tide reaching or retreating, you'll feel a little more connected, not just to nature, but to the entire universe that shapes it. Let your breath follow that rhythm now, in, out, like the tide. And as always, if you're enjoying these quiet explorations, don't forget to subscribe to Infinity Beyond. Every week, we bring you closer to the stars, one gentle question at a time. The gravitational pull of the moon is not the only force at play. Earth's shape, the rotation of the planet, and even the presence of the continents all contribute to the intricate rhythm of our tides. This means gravity doesn't act the same everywhere. It fluctuates slightly depending on where you are on the globe. These tiny variations, barely noticeable in our daily lives, further tweak the way tides behave across oceans and shorelines. So why do we experience two high tides each day? The answer lies in more than just the moon, tugging at the oceans like a cosmic puppeteer. It's the result of an elaborate ballet, a complex interplay of forces. The moon's gravity, Earth's constant spin, centrifugal forces from the Earth-Moon system, and the topography of the seafloor, which shapes the water's movement like a conductor shaping a symphony. It's not a ticking metronome, not a repetitive robotic clock. Instead, it's more like a slow-motion waltz, practiced over billions of years. The oceans swell and fall in a rhythm older than civilization, older than life itself. The water obeys, always. It flows and ebbs, retreats and advances, in step with the moon's quiet yet relentless command. This cycle, reliable enough that ancient sailors built entire calendars around it, can be delicate. Change the coastline by a few meters, and the rhythm shifts. Build a pier or a seawall, and you've altered the tune. But for the casual observer standing barefoot on the beach, it seems silent. You feel nothing. And yet the force that moves entire seas is moving you too, invisibly, persistently, just like gravity, just like time. Now, if the moon is the main performer in this celestial show, the sun is the special guest star, the one with a powerful voice that only sings at the biggest moments. While the moon is closer and thus has more influence over tides, the sun's gravity is still enormous. It can either work with the moon, amplifying its effect, or against it, diminishing the tide's reach. Let's look at the sun's credentials. It's huge, about 400 times farther from Earth than the moon, but also about 27 million times more massive. While its tidal force is weaker because of distance, when the sun, moon, and Earth align during full or new moons, their gravitational pulls combine. This creates what we call spring tides, not named after the season, but from the concept of springing forth. These tides are especially strong, with higher highs and lower lows, and they occur like clockwork twice a month. On the flip side, when the sun and moon are at right angles relative to Earth, during the first and third quarters of the moon's cycle, their gravitational forces partially cancel each other out. This leads to neap tides, which are gentler, with less dramatic highs and lows. So even here, we find rhythm and counterpoint. A cosmic duet, with verses rising and falling in harmony or discord, depending on the alignment of two celestial bodies. There's a profound beauty in this balance. Without the tides stirred by the moon and sun, Earth's coastlines would be stagnant. Nutrient cycles would halt. Marine ecosystems would struggle to thrive. Intertidal zones, the places where the sea meets the land, are some of the most vibrant habitats on Earth, teeming with life adapted to the constant push and pull of the ocean. And more than that, tides influence us too. From ancient fishing villages to modern shipping routes, human civilization has long depended on the tide's schedule. Our ancestors used the moon as a clock in the sky. Their lives moved in time with the tides. Even today, cities like Venice feel the moon's tug, and coastal dwellers still check tide tables before setting sail, casting nets, or digging for clams. In this dance of gravity and water, there's an unspoken understanding, an unbroken link between heaven and earth. The sea listens. It rises and falls in a silent song that spans millennia, and in the hush between the waves, you might just hear it too. The tide speaks not in words but in rhythm, and whether you're walking along a moonlit beach or drifting off to sleep, it's comforting to know that somewhere out there, the ocean is listening, just like you are now. When the moon is at its closest point to Earth in its elliptical orbit, a position known as perigee, its gravitational effect on the tides is even stronger. Now imagine this perigee moon aligning perfectly with a full or new moon, creating not just a spring tide, but an intensified version of it. This combination is known as a perigean spring tide, or more popularly, a king tide. These are the moments when the oceans rise highest and fall lowest, when seawalls are tested and shorelines seem to hold their breath. If a king tide happens to coincide with a storm surge, caused by wind and low atmospheric pressure, the results can be dramatic. Streets flood, beaches disappear, ports brace for impact. But even amid this surge of power, there's something meditative about tides. No matter how wild they get, they remain anchored in rhythm. A reminder that the world, for all its chaos, still moves to ancient, predictable patterns. The moon waxes and wanes, the sun rises and sets, and the oceans, in quiet obedience, rise and fall, echoing this cosmic cadence. In our busy, modern lives, buzzing with phones, alerts, and schedules, it's easy to forget that we, too, are part of this celestial choreography. The same sunlight that powers your morning coffee and warms the sidewalks also nudges trillions of tons of seawater gently across the globe. And that soft glow of the moon, peeking above rooftops, hovering over forests, is pulling silently on entire oceans. Without a whisper, without a tremor, it exerts a force so vast it moves continents' worth of water. Next time you see the moon rising full and luminous above the sea, or hear waves sliding away to reveal shimmering shells, pause for a moment. You are witnessing the work of cosmic companions, two great celestial bodies shaping the Earth together in a never-ending duet. But what if Earth were perfectly smooth? No continents, no mountains, no trenches, just one global ocean, wrapping a flawless sphere. In that idealized world, tides would be simpler. You'd see 2 high tides and 2 low tides every day, like clockwork. The ocean would slosh back and forth like water in a giant bathtub, rhythmic and even. But Earth, as we know it, is anything but smooth. Our world is bumpy, jagged, beautifully irregular. Continents block and redirect tidal energy. Deep ocean trenches absorb and deflect momentum. Shallow coastal shelves amplify tides, sometimes turning modest shifts into towering waves. This complexity gives birth to the diversity of tidal behavior we see across the world, from the nearly 16-meter tides in the Bay of Fundy to barely noticeable tides in parts of the Mediterranean. This chaotic beauty also means no 2 coastlines experience tides in exactly the same way. In some places, the tide comes in like a slow, creeping whisper. In others, it rushes in like a galloping horse, raising the water level by meters in just an hour. The Earth's rotation adds another twist, what we call the Coriolis effect. It causes tides to swirl around ocean basins like massive gyres, circling clockwise in the northern hemisphere and counterclockwise in the southern. This swirling pattern results in tidal bulges and troughs, forming amphidromic points, locations in the ocean where there is essentially no tidal movement at all. These points become centers of vast whirlpool-like tidal systems, with waves radiating out and rotating around them. The sea dances not just up and down, but sideways and around. It's as if the ocean were breathing in spirals. Now consider this. Even the land beneath your feet rises and falls slightly due to tidal forces. It's called earth tide or solid earth tide. Though much smaller than ocean tides, only a few centimeters, it's another reminder of how deeply gravity weaves through the fabric of our planet. The crust itself flexes in rhythm with the moon and sun. In this grand dance, time also plays a role. The moon is slowly drifting away from Earth at about 3.8 centimeters per year. As it moves farther, its tidal pull will weaken. Our days, currently 24 hours long, were once much shorter, just 18 hours during the time of the dinosaurs. As the moon pulls away, Earth's rotation slows down, lengthening our days bit by bit. So the tides not only move the sea, they are sculpting the future of our planet's rhythm. And just as they've been markers of time for ancient navigators, they continue to be markers of cosmic change. Tides don't just quietly run windway and lower the sea level throughout the day. Their influence extends far beyond what we see on the shore. They also create powerful tidal currents, shaping coastlines, reversing rivers, and orchestrating life itself. As these tidal bulges move across the globe, they pass through narrow straits, wrap around islands, and surge into estuaries, creating fast-moving flows of water that can sometimes turn entire rivers backward. One of the most dramatic examples is the Severn Bore in England, a rare tidal phenomenon where a surge wave rushes upstream along the River Severn. When conditions are just right, this bore becomes a standing wave several feet tall, attracting crowds of spectators and daredevil surfers who ride its muddy surge as far as they can. It's a moment when the moon's pull becomes a visible force, cutting against gravity's grain, defying what rivers are supposed to do. These powerful movements don't just affect thrill seekers, they reshape the land and life around them. Tides interact with local geography in ways that give birth to unique marine ecosystems. One of the most vibrant of these is the intertidal zone, the stretch of shoreline that is exposed during low tide and submerged during high tide. It's a boundary world, neither fully land nor fully sea, and it supports an incredible diversity of organisms. But the width and depth of intertidal zones vary greatly depending on tidal range, the difference in height between high and low tides. In places where this range is large, entire ecosystems must adapt to extreme changes in environment multiple times a day. Crabs scuttle into crevices to avoid the sun. Barnacles cling tightly to rocks to survive both dry spells and crashing waves. Fish navigate pools that may soon evaporate. Seaweed clings, bends, and breathes in rhythm with the returning tide. The tidal zone is a world of change, temperature, salinity, oxygen levels, all in constant flux. Life here is forged in resilience. Every living thing must learn to dance to the moon's rhythm or perish. It is one of the most demanding natural laboratories on Earth, where evolution thrives on adaptability. But the Earth isn't just a passive player in this dance. It's a living, shaping force, warping and redirecting the moon's gravitational energy in complex ways. The ocean floor, with its valleys, ridges, and plateaus, acts like a hidden landscape, sculpting every wave, every current, every splash against the shore. And beneath your feet, even when you're standing on solid ground, there lies a vast, unseen terrain. Submerged mountain ranges, ancient volcanic ridges, deep trenches, all silently shaping the ocean's journey. The tide doesn't simply crash against the land. It listens to it. It molds to its contours. It flows where it's guided and slows where it's restrained. Even more astonishing in some places, these tidal flows are harnessed for energy. Tidal power, the generation of electricity from the movement of tides, is one of the oldest forms of renewable energy. Ancient millers built tidal mills that filled with water at high tide and released it through water wheels at low tide. Today, modern engineers construct underwater turbines that spin in tidal currents, turning moon-driven motion into clean power. This power, though modest compared to wind or solar, is unwavering. Tides are not dependent on weather. They don't disappear on cloudy days or still nights. They are as reliable as the moon itself. In a world seeking stability in energy, that's a powerful promise. So the next time you're at the shore, watch closely. Notice how the waves touch the land and pull back again and again, where they rise, where they fall. Somewhere below your toes, invisible and ancient, the earth is sculpting every movement. And somewhere above your head, the moon watches quietly, pulling strings like a cosmic conductor. You may not see the pull, you may not hear it, but the whole planet responds. Rivers turn, shores flood, ecosystems awaken and sleep in time with a force older than mountains. It's easy to forget, amid the noise of modern life, that we live on a breathing, shifting world. But stand near the sea and listen. The tide is talking. Tides have never been static. Over millions of years, they've changed, shifted, and adapted. And now, in the present day, they are evolving once again, not just because of the moon's gradual retreat, but because of us. Climate change, sea level rise, and coastal development are subtly altering how tides behave. In some places, they're growing stronger, flooding further inland. In others, they're weakening, disrupted by dams, channels, and disappearing wetlands. We are entering a new chapter in the long story of Earth and the Moon. A chapter shaped not only by gravity and celestial mechanics, but also by human influence. And yet, through all this change, the moon still circles Earth with quiet certainty, faithfully guiding the tides in its eternal rhythm. That same moon glowing above us tonight watched over the dinosaurs. It shone on the first mammals creeping through ancient undergrowth. It was there for our earliest ancestors, standing on distant prehistoric shores, wondering about the sky. The continents may have shifted, the species may have changed, but the moon has never stopped pulling, and the oceans have never stopped responding. Sometimes the response is fierce, a massive storm tide, a thunderous flood. Other times it's gentle, a quiet ripple under a starlit sky. But always, always the tide moves, and always the earth listens. There's a quiet poetry in this ongoing exchange. Earth and moon, once part of the same body, were torn apart by a cataclysm billions of years ago. The moon was born in fire and fury, likely from a violent collision with a Mars-sized object named Theia. But from that violence came this enduring relationship, a gravitational bond that cannot be broken. The moon slows Earth's spin. Earth pushes the moon away, and in the space between them, something beautiful happens. We get the tides, that rhythmic inhale and exhale of the ocean, the steady breath of the earth, the heartbeat of every shoreline. So when you stand by the sea and watch the water rise and fall, remember, you're not just witnessing a moment. You're watching a process shaped over billions of years, a celestial conversation that began long before you were born and will continue long after you're gone. You are part of that story, even if just for a moment. A single line in a planetary poem, a flicker of awareness in a symphony that spans epochs. And whether you're watching the tide from a beach, a boat, or a quiet window, the moon is still speaking to the sea. And the sea is still listening. And what the tide brings is more than just water. It carries life. With each rolling wave, nutrients are stirred, fish are guided, larvae are dispersed. Tides feed coral reefs, refresh mangrove forests, and cleanse estuaries. For countless marine creatures, the tide is a signal. It tells them when to spawn, when to migrate, when to hide, and when to feed. For ancient coastal civilizations, the tide was a sacred clock. Temples and stone markers were built to track its rhythm. Myths and legends grew around its power. Gods who controlled the sea, moon spirits who govern the waters. Even today, festivals in many cultures still honor the moon's influence, from Lunar New Year's to full moon ceremonies by the ocean. And so the tide continues, part science, part soul, part story. It connects us to the moon, to our past, to the hidden pulse of the planet. In every wave that rolls ashore, there's a whisper of the cosmos, a memory from a time when Earth and Moon were one, and a promise that, no matter what changes on land, the ocean will still respond to the gentle tug of its ancient partner in the sky. Every time the tide rolls out, it leaves behind temporary microcosms, tidal pools, that brim with vibrant life. These miniature worlds are cradles of contrast, harsh and gentle, exposed and protected. A single pool might contain delicate clownfish darting through waving anemones, prickly sea urchins clinging to stone, and vivid purple algae spreading like ink across the surface. They're like reluctant roommates trapped between the pull of the sea and the promise of the next wave of freedom. Then, beyond the pools, rise the mangroves, those bristly, salt-loving trees with tangled roots that cradle the coasts of tropical and subtropical regions, from Florida to Bangladesh. These ecosystems are miracles of adaptation. Their roots trap sediment, protect against storm surges, and create nurseries for juvenile fish. Without the rhythmic nourishment of the tides, mangroves wouldn't flourish. And without mangroves, countless marine species and entire coastal communities would be far more vulnerable to flooding, erosion, and the growing threats of a warming world. Tides are not only architects of biology, they are weavers of culture. For as long as humans have watched the water, they have seen themselves in its movements. The tide has inspired songs, stories, and symbols, from ancient myths to modern metaphors. We speak of tides turning in our lives, of fortune rising and falling like the sea, of emotions surging, retreating, and returning again. The tide becomes a mirror, not just of Earth's gravity, but of the human experience. This poetic link isn't just superstition. It reflects something deeper, a subconscious resonance between our internal rhythms and those of the moon. Our ancestors knew the tide like we know the clock. Fishermen read the waves like you read weather apps. Farmers planted by lunar phases. Celebrations followed full moons. And while many of us may no longer live by the coast or harvest with the moon, we still carry that connection in the language we use, the art we create, and the feelings we sometimes can't explain. There's something grounding in knowing that the sea and the moon still keep time, even when we forget to. They don't need our awareness to continue. But when we pause and notice, standing barefoot on wet sand, feeling the tide swirl around our ankles, we're reminded of the deeper rhythm we've always belonged to. In that moment, you're standing not just on a beach, but within a living clock, one that pulses through coral reefs, sings through mangrove forests, breathes in estuaries, and flows through coastal bloodlines. This clock doesn't tick. It breathes, it hums, it nourishes, it sustains. It signals spawning rituals in fish. It tells turtles when to lay their eggs. It stirs the feeding grounds of whales and the floating journeys of plankton. It even sets the pace for the rise and fall of carbon exchange in marine forests, helping fight climate change without a single word. The sea, then, is not just moving, it is listening. And the moon remembers. It holds steady in the sky, circling above us all, gently guiding this liquid dance below. It doesn't ask to be watched, but it rewards those who do. Its pull is both ancient and present, gentle and vast. Even in our most advanced cities, tides still govern the rhythm of coastal life. Ports operate by their schedule. Engineers build according to their rise and fall. Fishermen still glance upward, just as their ancestors did, knowing that something far away is guiding the life beneath their boats. So next time you're near the sea, Whether in reality or just in imagination, take a moment. Feel the pulse. Smell the salt. Watch the waves kiss the shore. You are not separate from it. You are a part of its rhythm, shaped by its timing, inspired by its flow. The tide is not only a force of nature, it is a storyteller, and it tells a tale that links star and stone, moon and mangrove, science and soul. Tides might seem like a distant natural rhythm, something reserved for coastal beaches or fishermen's almanacs, but they are surprisingly present in daily life, even in places shaped by concrete, glass, and steel. In coastal cities, tides become a regular participant in urban planning, architecture, and even fashion. Rubber boots are not just accessories, they're survival tools. In places like Venice, tidal awareness is baked into every part of life, from transportation to tourism. Meanwhile, in the low-lying atolls of the Maldives, where land rises just a few meters above sea level, tides carry existential weight. A modest rise in water from a spring tide, especially when combined with wind or storm activity, can mean the difference between dry land and encroaching seawater. Here, the residents monitor the moon not out of romantic fascination, but as a vital necessity. Their homes, roads, agriculture, and freshwater supply are deeply tied to the ocean's moods. Every tide is a signal, a warning, and a hope. This close relationship with the tides is not just practical, it's deeply scientific. Oceanographers and climate researchers rely on tidal behavior to understand much larger systems at work. Tides act like giant tracer lines, revealing how energy moves through oceans. By studying them, scientists model global currents, track storm surges, and even monitor how climate change alters water movement patterns around the globe. Tides aren't just happening today, they've been happening for billions of years. And they've been leaving records behind. Layers of sediment, fossilized shoreless, and ancient salt flats all whisper stories of tides long past. By studying these clues, scientists can estimate what sea levels were thousands or even millions of years ago. They can infer past tectonic shifts, track the tilt and wobble of Earth's orbit, and piece together how coastlines have evolved over geological time. In all their complexity, tides serve as a beautiful metaphor. The same forces, the moon's pull, the sun's influence, Earth's rotation, act on the entire planet, and yet their expression is endlessly unique. It's as if one universal melody is being played through thousands of local instruments, each with its own tone, pitch, and rhythm. In one place, a tide may arrive like a whisper, barely disturbing the stillness. In another, it may rush in with thunderous might, churning sediment, stirring wildlife, and altering the landscape in minutes. The song of the sea, shaped by familiar celestial forces, never repeats itself exactly. It's written anew every day by the coastline it meets. And that diversity of experience is important, not just to appreciate, but to understand. If we want to predict how rising sea levels will impact different regions, or how a major storm might compound with a high tide to flood a city, we need to listen closely to the local tide's voice. We need to know how it behaves, what influences it, and how it has changed over time. From a scientific standpoint, tides are like a planetary pulse, a rhythmic, repeating signal that helps us measure Earth's health. They are tied to ocean temperatures, ice melt, wind patterns, and even large-scale oscillations like El Niño and La Niña. By monitoring tides globally, researchers can detect subtle shifts in the climate system, clues that something larger is stirring beneath the waves. But perhaps the most profound thing tides teach us is that no matter how advanced our technology becomes, we are still deeply, unavoidably connected to the rhythms of nature. Skyscrapers and satellites don't remove us from the moon's influence. Apps and algorithms may forecast the tide, but they don't change its schedule. The ocean listens only to gravity, time, and the celestial clock. We are participants in a planetary story written in salt and moonlight. Whether you live on a remote island, a coastal city, or a high-rise apartment far from the sea, the tide's message still reaches you, quietly, insistently, and eternally. As humanity searches for clean, reliable energy, the sea has emerged as a powerful ally. Tidal energy, once a curiosity, is now becoming a serious contender in the renewable revolution. But like all forms of innovation, it comes with trade-offs. Building tidal barrages, underwater turbines, or dynamic tidal fences can impact the natural rhythm of the ocean. Fish migration routes may be disturbed. Sediment flow patterns can shift. Salinity levels in estuaries may change, altering fragile ecosystems that have evolved to depend on the natural ebb and flow of the tides. Every benefit must be carefully weighed against potential environmental costs. If we change the way the tides move, we may also change the life that depends on them. And yet, the concept of drawing rhythmic, predictable energy from the moon's gravitational pull feels undeniably elegant. Imagine the power to charge your home, run your electric vehicle, or light your city, all quietly generated from the timeless dance between Earth and its lunar companion. It's energy not just from the sea, but from the sky, funneled through the waves. Unlike wind or solar power, which can fluctuate wildly based on weather or time of day, tidal energy is uniquely predictable. We can forecast tides centuries in advance. The moon never oversleeps. It doesn't forget. It rises, pulls, and moves oceans with a consistency that human infrastructure can rely on. That predictability makes tidal power particularly appealing for grid integration. Utilities can plan around its schedule with high confidence. While tides don't provide constant power, like a dam or a coal plant, they follow a repeating, dependable rhythm, creating 2 pulses of generation per day. In the coming decades, as the world transitions more seriously towards sustainable energy systems, tidal power could play a crucial role, especially in coastal nations and island communities. Infrastructure tailored to local geography, bays, straits, or estuaries, can make use of natural tidal amplification. And advancements in engineering may soon produce turbines that are cheaper to install, easier to maintain, and gentler on marine life. Imagine sleek underwater generators turning slowly with the tide, completely silent, invisible from shore, providing power without smoke, without fuel, without disruption. The vision is poetic and practical. Perhaps one day soon, the energy running through your kitchen lights, powering the train into your city, or even charging the device you're listening to this video on, will come not from fossil fuels, but from the ancient rhythm of the sea. A rhythm born not of combustion, but of cosmic choreography. And when that day comes, the moon will still be circling just as it has for billions of years. It will still be pulling gently at the oceans. It will still be moving entire seas, just as it moved the hearts of poets, scientists, and sailors for millennia. The future of energy may lie in returning to what is oldest and most constant, the tide. A pulse of movement, a breath of water, a gravitational gift. So, when we talk about renewable energy, let's not forget the sea. Let's not forget the moon. And let's remember that in the quiet rise and fall of the tide, there is not only beauty and science, but power. Cassini's mission may have ended, but its impact is still propelling us forward, literally. Thanks to the discoveries it made, especially about Titan and Enceladus, a new era of exploration is taking shape, one focused on a question more urgent than ever. Are we alone? 2 of the most ambitious missions currently on the horizon are Dragonfly and Europa Clipper, both designed to pick up where Cassini left off. Let's start with Dragonfly. Slated to launch in 2028, Dragonfly is a revolutionary rotorcraft lander, essentially a flying science lab that will explore Saturn's largest moon, Titan. Unlike the Huygens probe, which landed in one spot, Dragonfly will fly across Titan's surface, visiting multiple locations to conduct a wide array of scientific tests. Titan is unique. It has a thick atmosphere, liquid methane lakes, and complex organic chemistry. Dragonfly will analyze the surface for prebiotic molecules, the kind that might have kick-started life on Earth. It will study weather patterns, seismic activity, and possibly even signs of microbial life. But more than anything, Dragonfly represents a new model of mobility. It's the first mission of its kind, a drone on another world, hopping from site to site using its dual quadcopter rotors. Each flight will reveal a new piece of Titan's mysterious puzzle, enabled by what Cassini taught us about its geography and conditions. On the other side of the solar system, another icy moon is calling, Europa, one of Jupiter's most intriguing satellites. Beneath its cracked, frozen shell lies a global subsurface ocean, potentially holding twice as much water as Earth. Enter Europa Clipper, launching in 2025. This NASA spacecraft will perform dozens of close flybys of Europa, equipped with high-resolution cameras, radar, and spectrometers. Its mission: to determine whether the moon could support life, and if so, where we should look next. Europa Clipper won't land, but it will map the moon in exquisite detail, locating hotspots, measuring ocean depth, and even detecting potential plumes erupting from the surface. These plumes, like those seen on Enceladus, could allow future missions to sample Europa's ocean without drilling through kilometers of ice. The excitement surrounding these missions is electric. They are no longer theoretical, they're real, funded, and already under development. And they are direct descendants of Cassini's triumphs. But the story doesn't end with Titan and Europa. There are proposals for missions to Enceladus, including cryobot landers, orbiters, and plume samplers. Some designs even feature mini-submarines to one day explore the oceans hidden beneath the ice. And let's not forget exoplanet exploration. Telescopes like James Webb and the upcoming Nancy Grace Roman Space Telescope are scanning the skies for Earth-like planets and may one day find worlds even more compelling than Saturn's moons. In a sense, Cassini opened a gateway. It taught us that life may not need sunlight or surface oceans. It may hide in darkness, beneath kilometers of ice, thriving in places no one thought to look just decades ago. That idea has changed the course of astrobiology. It's changed how we design missions, where we search, and what questions we ask. And it's only the beginning. Next on Infinity Beyond, we'll zoom out for the big picture. What Saturn, its moons, and Cassini's findings mean for our place in the universe. And how the journey to find life beyond Earth is also a journey within. In the cold darkness beyond the asteroid belt, Cassini orbited a gas giant that, for centuries, was little more than a blur through a telescope. But in 13 years around Saturn, it became something more. A vessel not just of instruments, but of human aspiration. What Saturn gave us was more than moons, rings, or data. It gave us a mirror. Through Titan's methane lakes, we saw weather systems that echoed our own. On Enceladus, we glimpsed oceans that may carry the same spark that birthed life here. In the particles of Saturn's rings, we watched time unfolding, chaos becoming beauty, destruction creating wonder. And in Cassini's final dive, we saw the purest expression of exploration. Not for reward, but for understanding. Saturn reminded us that the universe is alive with stories, not always obvious, not always ours, but waiting for someone to listen. And Cassini, against all odds, listened. It's easy to see space as distant, unreachable, a backdrop for science fiction and mathematics. But Cassini brought it close. It made us feel the chill of Titan's skies, the thunderous silence of a ring shadow, the poetry of a signal traveling across 1 billion kilometers just to whisper, "I'm still here." And through it all, one truth became clearer than any image it ever sent. We belong to something greater. Saturn, with its impossible rings and secretive moons, is not just a planet. It's a reminder that in our pursuit of other worlds, we find reflections of our own. That exploration is not a luxury, it's a necessity. A declaration that we are curious, that we care to know, and that we are not done reaching. So as Dragonfly prepares to soar, and Europa Clipper sharpens its sensors, we carry with us the echo of a spacecraft that showed us how far we can go when we go together. The mission is over. The story is not. Because exploration doesn't end at Saturn. It doesn't end with Cassini. It continues every time we look up and ask, what else is out there? And more importantly, what does it say about us? This is Infinity Beyond, where wonder has no boundaries, and the journey never ends.